So we know, because I know that you know, that if you want to print something out to the terminal screen, you've got to use our good friend cout to do so. So let's cout something to the terminal. And then when we run this, well, we see that something does indeed print out to the terminal screen here, but we have two statements in this code that output something to the terminal screen. First, this cout line that prints something, and then we have this return zero statement that prints out process returned zero, and yada yada. So that being said, all of this looks like it could be one singular output. So let's put some space between them. And no better person to invite to the party than inline. And so let's drop down a line after we've printed something. And then when we do that, then something prints out to the screen. We have a nice space, and then we have a different output that's apparent because process return zero is a different output. And so, yeah, that fixes everything, except for that inline was completely unnecessary in this situation, and we could have invited somebody else to the party. We could have invited instead new line character. And new line character looks like this, a backslash and an N. Now, fun fact, C++ treats both of these characters together, this backslash and this N, as if it's a single character. Well, it's not really fun, but it's a fact. The way that it stores the memory, it's a single character. And what's going on here is that when we print this out, we see that, well, it indeed acts kind of like inline. It drops down a space, but we don't see any backslashes. We don't see any ends. And so how does that happen? Well, as it turns out, this backslash has a special relationship with C++ when it's included in a string like this. C++ knows better. You don't print out this backslash. It knows. It's taken more as a heads up that there's going to be a single character afterwards that has some sort of special meaning. And this single character is going to be packed with some sort of hidden instructions on what to do next. And so after C++ sees this heads up backslash and it sees this N stands for dropping down to the new line. And there's different characters that can come after the heads up backslash that do different things. And so this new line character here belongs to a broader family of things called escape sequences. And all escape sequences sort of have this format here. They begin with a backslash that C++ knows not to print out, but instead treats it as a warning that, hey, there's going to be a character coming up, and whatever character comes up, well, do that thing. And different characters do different things. To prove that it's only a single character that's considered here, let's do this. Let's print off something to the screen, and then we're going to put this new line character here to drop down to the next line. And then right on the tail end of this, let's print out, I don't know, something else. And then let's see what happens. So let's run this, and we see that something prints out to the screen as the beginning of this line would sort of indicate here. And then this new line character pops up. We drop down a line, and then we print out something else. So it's obvious that this something else was never considered as part of this special instruction. It was printed out. Just this backslash that was taken as the heads up, and then this N was considered as this escape sequence, right? And so let's drop down some more lines because our outputs are commingled again. And as it turns out, we can stack these. We can drop down as many lines as you want. So when we print this out, well, something drops down a line, something else, and then drops down several lines. So you can stack them like that as long as each of them has their own individual backslash. Now, that being said, what are some of the other escape sequences that we can learn? Well, new line is probably the most common one. The second most, I would say, is probably the tab escape sequence. And so we can cout something to the screen like, hey, and then we can put a backslash T for tab, and we can stack that one too, and we say U, tab over another several times, and then we can say guys, and then we can drop down a couple of lines. So you can even use different types of escape sequences within the same line. And so let's see this one in action. Let's print this off to the screen, and we see, hey, bunch of tabs, you, bunch of tabs, and then guys, and then we drop down a couple of lines. Let's see, what's another one? Let's do backspace. So we can see out to the screen, ABC, and then we can put a series of \B's to sort of destroy everything that we've just put out to the screen, and that's why we can't have nice things. And then we can DEF this bad boy, and then drop down another couple of lines, and when we run this, well, all we see is DEF because ABC was completely just deleted by our irresponsible use of backspaces. So the next one I want to show is maybe, well, what if you want to see the backslash? Notice that we have just a metric load of these backslashes throughout this code here, but nary a one of them appears on the screen. They are all ignored. Well, what if we wanted to see a backslash? So let's see out that to the screen with maybe the only phrase that I know that contains a backslash, and we'll say AC backslash as a heads up, backslash as print a backslash, DC. So no surprising there. And let's drop it down another couple of lines after that. And we see that we have two backslashes in the code because one of them's the heads up, but we only have one backslash as the output. And this will always be a 2-to-1 ratio. Like if we were to put 4 backslashes in the code, well, we would get 2 backslashes in the terminal. And so it always sort of follows that pattern. Next, I don't know how much you've experimented with cout yet, but if you've ever tried to put quotation marks within an output, well, you may have been surprised because, well, here you see that we have quotation marks just all over the place. Every line has one, but you don't see any quotation marks when we print things out, just the stuff that's in the middle. And so what if we wanted to create some sort of line that said, I don't know, made with quote unquote real, wink wink, nudge nudge, cheese. And so we try to print this out. Maybe we drop a couple of lines at the end. What happens here is that C++ doesn't know what we're talking about. The way it's viewing this scenario is that we wanted to print made with real and then a space, and then that's the end of our string. When we put this set of quotations right here, that's the end of the string that we wanted to print out to the screen. And then the rest of this is nonsense. What do we mean here or whatever? So if you want to print out these quotation marks, well, you put a backslash in front of them, kind of like it's an escape sequence. Well, because it is. And so now when we run this, we see that the quotation marks pop up to the screen. And if you wanted to do single quotes, it's the exact same process. And so we can see out to the screen made, let's fix that, made with allegedly real cheese, but this time we're using single quotes as our escape sequence. And so let's finish typing this out, drop down a couple of lines, semicolon this bad boy, and run this program. And so made with real, single quotes this time, cheese. Now, one more that I'm going to show you is a little alarm. It's a little audio alarm that you can use to get the user's attention real quick for whatever reason you have for that. And so we can include some sort of quotes here. Hey, and then we can put some exclams at the end of it, and then we can put a backslash A at the end of this for alarm. Maybe we drop down a couple of lines afterwards too. And so let's run this, and there's your alarm. Now, this is the only one that I know of that doesn't really stack well. You can put a bunch of these in here, and same thing. It doesn't really echo, it doesn't really repeat, it doesn't do it louder, it just does the same thing. So one will do her on this alarm thing. So here's some of the common escape sequences. There's more, but these will get you by probably most of your coding career because the uncommon ones are super uncommon. The tabs, for instance, just as a pro tip, are great for making tables with to make sure that everything is evenly spaced out. All right, see you in the next one.